Here we go. Angles and lines revision. So in most of the problems, you need to be able to find values of unknowns. So let's have a look at the first problem. It's not so complicated. You have two parallel lines, you have a second line and two unknowns. So simply x is the single unknown, but you need to find all the angles and finally find x. Okay, pause the video and try to go by your own. Here are my explanation. So what we can do, we can figure out this angle, and simply if you add 2x with something, you'll get 180. But unfortunately you don't know x, that's the problem. So that's why what you're gonna do is to find the following. Let's consider two vertically opposite angles. They should be the same, so that's why it's also 2x degrees. And what about 2x and 1 over 2x, 0? 2x plus 1 over 2x should be 180. So because you know, if you consider alternate angles, that's also 2x. And in total, if you add 2x and 1 over 2x, you'll get 180. Because they, if you add them up, you'll get 180 out an open angle. So let's do it quick. You'll get 5x over 2 is 180. So x is 2 over 5 of 180, but I will write like 18 times 10 and simply cancel that. So I'll get 2 times 8 is 36 and times 2, 72 degrees. So for each x there is 72 degrees. So the total value here is 36 degrees, and this is double the quantity of 72. It's 144. Alright, let's move to the next. So problem number 2, again find unknowns. So we have x and y, two unknowns. What we can do, alright, let's try to figure out x. So x is also here, and x with 60 and 70 will arrange 180 degrees as an open angle. So from here x is simply just 50. Alright, so we know x and we need to find y. Okay, we have two parallel lines. Does it make any sense? I guess yeah, because 180 and 70 sort of corresponding angles, so y is simply 70. Okay, we fixed it out. On the top of that we can even find that z. So let's say z plus y plus x will arrange 180 according to the sum of the angles in the triangle, and from here we can even figure out z. So it's 180 minus y minus x. 180 minus 120, which is 60 here. Next one, problem number 3. So we have 2x plus 2 and 40 and 90 degrees angle. Alright, so we'll put 90 and we'll arrange 2x plus 2 plus 19 plus 40, which is 130, is 180. That's open angle. So from here, 2x is simply, that will be 1548, and from here x is 24 degrees. Okay, let's go to problem 4. So we have, right, so we have three angles centered at one point, so if you add them up, you'll get 360. In this case, because of the full turn, so in this case you simplify that and you'll get 7x over 2, which is 330, and from here x is the fraction 2 over 7 times 330. So just use calculator and calculate. Next one, problem number 5. So 70 and x plus 5. Alright, what we know about them, two parallel lines and a second line. So that's the second line, the line that cuts parallel lines in 2 points. So what we know, they are correspondent. They should be the same. If you're not sure, you can go to vertically opposite, and then 70 and x plus 5 alternate angles, they're also the same. Alright, so we have 70 equals to x plus 5, from where x is simply 65. Let's move next. Alright, problem number 6. 3 angles in a triangle. Well, we know if we add them up, we need to add them up, and hence we arrange 180 degrees according to the property of the sum angles in the triangle. So we'll get 6x equals 180, so for each x, stay 1/6 apart, so simply 30 degrees. So problem number 7, so we have right angle triangle, 60 degrees and some angle x. Okay, so we can figure out this angle as 180 minus x, from where 180 minus x, one angle. The second angle should be 90 degrees, or you can sum them up and get 180. So I use a shortcut. So x is simply 90 plus 60 is 150. Oops, yeah, that's correct. Okay, next one, problem number 8. So we have an isosceles. So we have an isosceles triangle. So that's why x should be equal to y because of the property. So two angles at the base should be the same. So that's why we know that. That's why instead of y, we can consider as x. And lastly, 30 with, let's say, 2x's should be 180 together. So 2x is 150, and x is simply half, 75. So y is also 75. So number 9. What can be inferred about triangle LKM? So we have a triangle, we have the measure of the top angle 46, and this is 134. So we simply can calculate this angle, because in those sort of problems you need to tend to get into interior angles of the triangle. That will be helpful. So 134 and 180 minus 134, that's how you can figure out angle MLK. So it's simply 46. So because we know two angles the same at the base, so this is the base, we can consider triangle LKM as an isosceles with two equal sides. LK equals MK. So okay, that's an isosceles triangle as the result. Next one. 10. Find unknowns and state what can be inferred about triangle ABC. Okay, let's zoom out. What can be inferred and find unknowns. Okay, we have two equal sides, so AB equals BC. So that's also 2x. And we have another variable y. So this is y. And we know also the angle is 60 degrees. Okay, so if the triangle is an isosceles, this angle is also 60 at two angles at the base. So it looks like the top angle is also 60 because 180 minus 120 will get angle B, and which is 60 degrees. So it looks like triangle is equilateral. So all sides the same. So that's why AC should be equal to 2x. But let's consider, because we have so a bisector that splits AC, because its height, and height in triangle becomes an angle bisector and the base bisector. So height equals bisector in terms of angles and the side. So this is also y, but we know 2 y's is simply 2x. So all sides the same. All right, so how we can figure out what stays for each one? So we know now triangle is equilateral and all sides is double x. How we can figure out x value? So we can consider a half of that, and we know that this part simply, this blue part is simply x, right? Because it's half. And we know the angle 60, so we can hire trigonometry. So plus trigonometry, and we'll be able to figure out x value. So we know that this is adjacent side. Adjacent, so this is height. So 2x is simply height. Adjacent is equal to height times cos 60. All right, so if we apply that, we'll get that. All right, but it doesn't make any sense. 60 is 1/2, and we never be able to find that. All right, but what if we calculate this rule? Can be inferred. So we answered that this triangle is an equilateral, and we also need to find unknowns. That's a problem. I think this sort of it can state about x. So the answer x is impossible to find. Possible to find. But we also can establish the relationship between y and x. So y is simply equals to the x. That's the only fact that we can establish. All right, so it looks like we don't have enough data. All right, so next one, 11. So we have z angle, x and y, and we have also 35 degrees. So it looks like 35 degrees here, 2 parallel lines, right, and corresponding angles. Okay, so we have triangle to be an isosceles. Okay, so it looks like z is also 35 because 2 angles at the base. Okay, so we found z. We can figure out x. Okay. It's very, very interesting. You know what? Because the bottom triangle is... Oh, okay. No matter. So yeah. Actually, I consider this side equals to the top side. So according to the picture. Alright, so we found that z is 35. So we can figure out x also. So 2 times 35 and plus x will give us 180. So from where x is simply 180 minus 70 is 110. Okay, this is the value. And because this angle and this angle should be the same because of 2 parallel lines, so we can state that y is also 110. Okay, it's done. Okay, so problem number 12. We have sort of trapezium with 90 degrees angle and 2 parallel lines, so it looks like this angle is also 90 degrees. Okay, so what do we know about the sum of angles? Sum of angles and quadrilateral if we add them up, 65 plus 90 plus 90 and plus finally x should give us 360, because remember n minus 2 times 180 where n number of sides of the polygon. So in this case, n is 4, and we simply have 360. Okay, so from where we can figure out x. X is 180 minus 65, so x is simply 15 degrees. Oh, it doesn't look like it's 15. So one more time, check. It may be not to scale, right? Not to scale. Okay, I'm pretty sure. So 90, 180, yes, 180 minus 65. Oh, my bad. It's 115. So I return my words. So it looks like, yeah, 115, that's okay. So we know x is 115, so we can figure out angle that add x to 180. So it's simply 65. Yeah. So this interior angle in the triangle is 65, and because it's isosceles, we also can figure out that z is also 65, and the rest part for y, simply use the property for the sum of the angles. So 65 times 2 will get 130. That means y is just 50 degrees. Okay, we figure out all the angles. So and see itself. Problem number 13. All right, we have so we have this 130, 120 and x. Okay, so our goal is to find x. So it seems to me that we need to figure out all interior angles. So 120 and 60 here, so 70 here, just simply a straight line, yeah, and 180 together. So 60 and 70 is 130, and 180 minus 130 will give us the value for x. So that's simply 50 degrees, right? So the problem 14, what we have here, 90 degrees, and 110. So tends to go into interior angles. That's quadrilateral. So if we know like most of the angles, we can complete the sum of interior angle, sum interior. So for quadrilateral, we should have 360 in total. Yes, again, n minus 2 times 180. This stays this for the sum of interior angles. Okay, so in this case, sum of interior, first of all, we need to find as much as we can, as many as we can interior angles. So that's 70 stays here. That's 90, that's also 90. Oh, it's pretty easy. And here we have unknown, but we know that this is y minus 180 in total. So let's sum up. 180 plus 70 plus y minus 180 will give us 360 in total. Okay, so subtract, cancel is better, and 360 minus 70, so y is equal to 280. Yeah, so fair enough, and not to scale, I guess. Not to scale. Okay, so yeah, that's the end. We figure out all the values, all unknowns. So it's pretty, it's for, I think, not higher GCSE, but sort of middle level. But it's good practice about angles, lines, and probably part of polygons. Hope you enjoy. Hope you done in the same manner, maybe faster. That will be good. So, see you later, guys.